atmosphere protects and supports our life.
What would happen without the atmosphere?
The oceans would not exist and life would not survive. The planet would be a lifeless rock.
So, altitude is the distance above sea level.
They found that the air becomes thinner as altitude increases.
If two objects take up the same amount of space, then the object with more mass has a greater density than the one with less mass.
The atmosphere's density decreases as you travel upward. For example, the air on top of a mountain is less dense than the air at sea level. Higher up, at altitude where jets fly, a breath of air would contain only about 1/10 the mass of air at sea level. There is no definite top to the atmosphere. It keeps getting less and less dense as you are farther away from Earth's surface. The decrease of density with a greater altitude means most of the mass of the atmosphere is close to Earth's surface.
Within our atmosphere, there is 78% nitrogen, 21% oxygen, and the rest is argon, carbon dioxide, other gases such as that. Also within that is water vapor, and water vapor is going to vary depending on where you're at in the world and what time of the year it is. Sometimes it can have a great amount of water vapor in the air, and sometimes it'll have none. And water vapor can actually make up to 4% of the air around us.
Water vapor, carbon dioxide, and other gases in the atmosphere are affected by both ongoing processes and sudden changes. When you breathe, your body exchanges gases with the atmosphere. 3 of the most important cycles that affect the atmosphere are the carbon cycle, the nitrogen cycle, and the water cycle. The carbon cycle, carbon dioxide and oxygen gases constantly circulate or cycle among plants, animals, and the atmosphere. The nitrogen cycle, different forms of nitrogen cycle among the atmosphere, the soil, and living organisms. The water cycle, different forms of water cycle between Earth's surface and the atmosphere.
Energy from the sun heats the atmosphere. Some energy is reflected while the rest reaches the earth.
As the sun energy enters the earth, you're going to see about 5% of it is going to reflect back off the surface. 25% of it is going to be reflected by clouds and Earth's atmosphere. 20% is going to become solar energy that is absorbed by the clouds in the atmosphere. And 50% of it is going to be absorbed by the Earth's surface, and it's going to heat the Earth's surface.
70% of solar radiation that reaches Earth is absorbed. Most of it is absorbed by oceans, landforms, and living things.
The absorbed energy heats the Earth's surface.
Air moves energy and spreads it around, and it does this in 3 different ways. Those ways include radiation, conduction, and convection. Okay, remember that radiation is when the sun's rays come through and it is used to heat the surface of our Earth. Well, this also heats our air, and that is because some of the gases within our atmosphere are able to trap that infrared radiation, which in turn heats the air. The second form is conduction. Now, conduction is the transfer of heat energy, but it's only done when one substance directly touches another substance. This heats the atmosphere when the atmosphere directly touches the hot surface that has been heated in radiation. When the gas molecules in the atmosphere touch the surface, they transfer the heat between the two, which causes the air to heat. And the final method is called convection. Take a look at this picture. In here, we are seeing a convection current. Remember that in a convection current, cold, dense air is going to go downward, while hot, less dense air is going to rise. So these 3 processes work together. As radiation heats the surface of our Earth, conduction is going to transfer that energy from the surface of our Earth through the air molecules from touching. And then convection is going to take those warmed molecules and have them rise, while colder, denser air is going to go closer to the surface of the Earth, and the process is going to repeat. One of the main things to know about our atmosphere is actually covered within this section, and that is that there are layers in our atmosphere and how those layers work. The very first thing to know is to know all of the layers of the atmosphere. Now, there are approximately 5 layers, well, 4 layers, and then one is actually broken down into a couple of different layers. And those start with the troposphere. The troposphere contains about 80% of the mass of our atmosphere, and this is the layer that has most of our weather in it, and this is where most of that heating occurs that we just talked about. Next up is our stratosphere. Our stratosphere is a layer that contains our ozone layer. We'll go more into the ozone layer later, but this is the layer that is very important to us as it does trap most of the radiation that is harmful to us. You'll note that here in the stratosphere, this is where the temperature, instead of going from hot to cold like it did in the troposphere, in the stratosphere it's actually going to go from cold to hot. And again, that has to do with that ozone layer and how it traps the ultraviolet radiation. Next up is the mesosphere, and in the mesosphere, this is where the meteors that try to enter Earth's atmosphere burn up, and so the mesosphere protects us from those meteorites. And our last layer is the thermosphere. Now, the thermosphere is actually broken out into 2 sub-layers, and those are the ionosphere and the exosphere. But our thermosphere consists of everything from that 90 kilometers out all the way up out into outer space. There is no definite outer limit to the thermosphere. It continues and continues. Now again, that thermosphere is broken out into those layers. So the way this would work is troposphere, stratosphere, mesosphere, thermosphere, and then sometimes exosphere is on top of that. But again, it's actually a portion of the thermosphere, but sometimes it's considered kind of a sub-layer. All right, let's talk some more about that ozone layer that we talked about. The ozone layer, again, this is going to trap that ultraviolet radiation that can really harm us. Ultraviolet radiation is the thing that causes sunburns and other hazardous things that can happen to your body. Remember that ozone molecules, these are made up of 3 oxygen atoms. Unlike the oxygen that we breathe, which is 2 oxygen atoms formed into one molecule, this is 3 oxygen atoms. These ozone molecules are very important. Again, they protect us from that harmful ultraviolet radiation, but they let through other types of radiation that are good for us, such as visible light. The ozone molecules that stay up in our stratosphere, they're a natural process, and they can actually be destroyed and form again naturally within the cycle, and this can continue endlessly if there are not other factors that factor into it. Within our atmosphere, there are greenhouse gases, and these gases are going to trap some of the heat in our planet rather than letting it escape. If we were to not have these greenhouse gases, our temperature would actually be very, very low. But because we're able to trap some of the gases, we still let some out, but we trap some of them, it keeps our Earth at the temperature that it's supposed to be. At the same time, it's important that some of this energy is released back out into space, because if we were to trap all of it, then our Earth would actually become too hot. Pollutants are things like smoke and other harmful materials that are added into our air, and that air pollution can come from anywhere in our world. Pollution that happens in one part of the world can be transferred through our air to another part of the world. And there are 2 different types of pollutants. There are gas pollutants and particle pollutants. And an example of gas pollutants is our ozone. Now, even though our ozone is very important to us up in the stratosphere because it blocks those ultraviolet radiation rays, but when it comes down into the troposphere, it can actually be a problem because it can harm humans and other animals, and down here in the troposphere, it's a pollutant. Particle pollutants are actually easy to see, or easier to see. These include tiny particles of droplets that are mixed in with our air. This is things like smoke, smog, and pollen, dirt, dust, and even little bits of salt from the ocean. The majority of pollutants that we see in our cities and suburbs come from the burning of fossil fuels. Remember, these fossil fuels are these non-renewable resources that are in things like our gasoline and our oil and our coal. These are things that have been building up for millions of years that come from animals that died millions of years ago. But when we burn these cause problems in our atmosphere, which in turn cause problems with where we live and how we live. The effects of pollution can actually cause problems for the health of humans. Gases and chemicals from particulates actually move through your lungs and other parts of your body. People who exercise outdoors, or people with problems like asthma, or young children or older adults are the ones who are particularly susceptible to having problems with air pollution. At the same time that pollution is causing trouble to humans, it can also cause trouble within our atmosphere. When the particulates get up into the atmosphere, it can either reflect or absorb sunlight and can even affect our weather. And as rain clears these particulates from the air, which is great for our air, it actually brings those particulates down into our ground and lakes, our oceans, continuing to cause issues. Human activities are actually one of the biggest contributors to our problem with greenhouse gases. Carbon dioxide that comes from our vehicles and our houses and our factories, these are the biggest problem that we have within our atmosphere. As we know, global surface temperatures have been changing over the last 100 years, and this is not good for our atmosphere, and this is caused by those greenhouse gases. Particularly that carbon dioxide that we just talked about, that can stay in our atmosphere for more than 100 years. In order to protect our world from situations such as the one you see on your screen, where our ozone layer actually has a giant hole in it, we need to do many things. That includes things like making sure that we're using less fossil fuels, using our cars less, living in houses that are better energy efficient, not cutting down our forests. These kind of things you want to do in order to help our world and to decrease the amount of greenhouse gases. And as I wish you always, good luck on your test.